Hi everyone, we will start with this example. So in part A we have limit e to the power sine x when x goes to 0. So it is a direct substitution and the answer is e to the power sine x or sine 0, sorry, and e to the power sine 0 equals e to the power 0 since sine 0 equal to 0 and e to the power 0 equals to 1 as you see here. Any number to the power 0 equals to 1. For the second part, we have limit cosine x squared minus 4 divided by x minus 2 when x goes to 2. If you plug in the value of x here, you will get 2 squared 4 minus 4 equal to 0 divided by 2 minus 2 equal to 0. So we have limit cosine. We can factorize x squared minus 4 because as you know that a squared minus b squared equals a plus b multiplied by a minus b, and we can write 4 as 2 squared. So we have x squared minus 2 squared, which is equals to x plus 2 multiplied by x minus 2 divided by x minus 2 when x goes to 2. Now you can simplify by cancel x minus 2 with x minus 2, and you have to plug in the value of x inside the angle. So we have cosine 2 plus 2, which is equals to cosine 4. And 4 is not a remarkable angle, so it will be cosine 4, and you can use calculator to find what is the value of cosine 4. Now in part C, we have limit ln natural logarithm of x plus 1 divided by x when x goes to infinity. As you know, when you want to find the limit when x goes to positive infinity or negative infinity, you have to take the term with highest exponent up divided by the term with the highest exponent down. So the highest exponent up is x and the highest exponent down is x. So we have limit ln x divided by x when x goes to positive infinity, and x divided by x equals to 1. So we have ln of 1, and as you know that ln of 1 equal to 0. Now in part D we have limit cosine the angle 2 tan inverse of x. As you know that tan inverse of negative infinity equals negative pi over 2, and also tan inverse of positive infinity equals pi over 2. So by direct substitution to x goes to negative infinity, it will be cosine 2 tan inverse of negative infinity, and tan inverse of negative infinity equals negative pi over 2. So we have cosine 2 multiplied by negative pi over 2. Simplify by cancel 2 with 2, you will get cosine negative pi equals to negative 1. Now in part E we have limit sine inverse of x divided by 1 minus 2x when x goes to infinity. When we have a polynomial divided by polynomial and x goes to positive or negative infinity, you have to take the highest power up and the highest power down and cut the other terms. So we have this one and this one. So we have limit sine inverse of x divided by negative 2x when x goes to positive infinity, and the answer will be, when you cancel this one with this one, will be negative 1 over 2. So we have sine inverse of negative 1 over 2. What is the angle that have the sign minus 1 over 2? This angle is negative pi over 6. Now next in part F also we have the same idea. We have limit when x goes to positive infinity for the function sine pi x divided by 2 minus 3x. So you have to take the highest power up over the highest power down, and this will be limit sine pi x over negative 3x when x goes to positive infinity. Now by simplify and cancel x with x, you will get sine negative pi over 3, and sine negative pi over 3 equals to negative radical 3 over 2. And this is the final answer of this example. And that's it. In this example, you have to know the main important theorem that will help you to find the limits of any trigonometric ratios inside. So this is the theorem to the right, and you can see that limit sine mx divided by nx equals m over n, okay, and limit mx divided by sine nx equals m over n, also about the tan and sine over tan and tan over sine. We will start with these direct questions. The first question is limit sine 3x 3 theta divided by theta when theta goes to 0. Now you can apply these theorems for this example because the coefficient of theta down is equals to 1. So by using this rule, you can see that this limit equals 3 over 1, which is equals to 3. For the second, next, we have a limit tan 4x divided by pi x when x goes to 0. Pay attention here. You cannot use you cannot use this theorem unless x goes to 0. When x goes to other number than 0, you cannot apply this theorem. So this theorem can be applied when x goes to 0. Now we have tan 4x divided by pi x, which is almost this one, okay. Tan mx divided by nx equals m over n, and here equals 4 over pi, the coefficient of x up divided by coefficient of x down. For the next one, we have limit sine radical 3x divided by sine 5x. It is almost this one, sine mx over sine nx equals coefficient up divided by coefficient down. But remember, x goes to 0 only. So we have radical 3 over 5. For next one, this is equals to, this is almost this one, limit mx divided by sine nx when x goes to 0. So this is equal to 16 over 2, which is equals to 8. For the next one, tan over tan, this is tan over tan equals m over n, coefficient up 55 radical 3 divided by 11, and 55 over 11 equals to 5. Then you have to put radical 3. The last one for the first part, we have limit sine 25x divided by tan 5x when x goes to 0. Sine over tan, that's it. Sine mx over tan m, and x equals m over n. So here this limit equals to 25 over 5, which is equals to 5. In part G and H, you have to do more before. It's not a direct application. You have to simplify firstly, then you can get the final answer. So here, sine square of x means sine x times sine x, as you know. And 3x square means 3 times x times x. So we can write this one as limit 1 over 3 multiplied by sine x over x square. And x means 1x. And here means 1x. So when x goes to 0. So it will be equals 1 over 3 multiplied by this theorem, sine mx over nx equals m over n. This equals 1 over 1, and you have square. So 1 divided by 1 equals to 1, square equals to 1, multiplied by 1 over 3 equals 1 over 3, and 1 over 3 is the final answer of part G. Now for the next one, part H, we have limit x squared minus 3x divided by x. Firstly, you have to distribute x first and x second. So we have limit x squared divided by x minus 3 sine x divided by x when x goes to 0. And since we have subtraction here, you can distribute the limit for the first one and second one. Now for the first term, we have x squared divided by x, which is equals to x. So we have limit x minus 3 limit sine x over x when x goes to 0, when x goes to 0. Now limit x when x goes to 0 equal to 0, you have to plug in 0 minus 3. Now sine x over x means sine 1x divided by 1x. And by using this one, the first one, it will be 1 over 1, which is equals to 1. And the answer is negative 3. In part I, find a non-zero value of the constant k that makes f of x equals tan kx over x when x less than 0, and 3x plus 2k squared when x greater than or equal to 0, continuous at x equal to 0. Continuous means that limit from right of 0 equals the limit from left of 0. So limit f of x when x goes 0 from right equals limit f of x when x goes 0 from left. And 0, if from right, as you know, it means greater than 0, and 0 from left, it means less than 0. So you have to replace 0 on the second function to find the limit to the right of 0. So we have 3 multiplied by 0 plus 2k squared equals the limit from left. And the limit from left is limit tan kx divided by x when x goes to 0. Now 3 times 0, 0 plus 2k squared is 2k squared equals limit tan kx divided by x. It is exactly the first rule here. So you have to take the coefficient of x up divided by the coefficient of x down. So we have k over 1, which is equals to k. Now we have to move k to the left hand side and take k as common factor, and you will get 2k minus 1 equal to 0. By solving, you will get k equals 0 or 2k minus 1 equal to 0. That means k equals to half, 1 over 2. But k equals 0 is rejected because a non-zero value of the constant k. So you have to find the non-zero value of the constant k, and the answer is k equals 1 over 2 only. And this is the value of k that makes the function continuous at x equal to 0. And that's it. Thank you.